Makinig, manood, nasa teleradyo. Makinig, manood, nasa teleradyo. Teleradyo, Teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kaakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito, tiyak ang pagkatuto. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo.
Good morning, Delpilarians. Welcome to another day of fun-filled learning experience. I am Cristina T. De Vera, your Math 7 teacher here at Teleradyo Marcelo, ang telearalan ng bawat malulenyo. Today, we will explore an interesting topic about parallel lines cut by a transversal. But before we have the core of our lesson, let us look back at the previous lesson that we've taken up by doing this Name Me activity. So as the title suggests, you must name the angle pairs being described in the following statements. So for number 1, two coplanar angles that share a common side and common vertex. So if your answer is adjacent angle, that is correct. Number 2, two angles whose degree measure when add up is equal to 90 degrees. If you have complementary angles, you're correct. Number 3, any two angles whose sum of their degree measure results to 180. And that is supplementary angle. For the fourth one, these two angles have to be adjacent and supplementary and create a line. And that is linear pair. And the last one, two non-adjacent angles formed by two intersecting lines. They are opposite angles and at the point of intersection and are equal to each other. And of course, that is vertical angles. Okay, we have another activity that will surely refresh your knowledge of the week 2 lesson in this drill. So in this drill, you have to identify the angle pairs illustrated. So for figure number 1, we have angle 1 and angle 2. If your answer is supplementary and linear, it's correct. Number 2, focus on angle 1 and angle 2 alone. So what kind of angle pair is illustrated in figure number 2? And that is adjacent. Next, number 3, we have figure number 3, angle 1 and angle 2. So when taken together, they are called as supplementary angles. For number 4, we have 47 degrees and 43 degrees. And when combined, they will be called as complementary angles. Number 5, angle 1 is opposite angle 2, and this is vertical angles. We just look back to this angle pair because it is essential in our current topic, and we can still use these angle pairs in solving problems related to our lesson. So the learning competency for this week, the learner derives a relationship among angles formed by a parallel lines cut by a transversal using measurement and by inductive reasoning. So let us now identify the objectives for this week's lesson. So after going through this module, the learner are expected to identify the angles formed by the parallel lines cut by a transversal, determine the relationship between pairs of angles formed by parallel lines cut by a transversal using measurement and by inductive reasoning. So let's begin. What do you call two lines that do not intersect? And that is parallel lines. Parallel lines are coplanar lines that do not intersect. The symbol for denoting parallel lines is this double bar. Say, for example, if we have line A and line B. From the illustration, we can say that line A is parallel to line B. Okay. So what will happen if parallel lines are cut by transversal? If a set of two parallel lines are cut by transversal, then each of the parallel lines has four angles surrounding the intersection. Say we have line A and line B. Okay, these lines are cut by transversal line C. Around the intersection of line A and C is angle 1, angle 2, angle 3, and angle 4. Likewise, on the intersection of line B and C, we have angle 5, angle 6, angle 7, and angle 8. And these are the four angles surrounding the intersection. Based on the description, how can we formally define transversal line? A transversal is a line that intersects two different lines in two different points and form angles. Say we have line M and line N. So this is cut by a transversal line. And around that are angles 1, 2, 3, 4, 5, 6, 7, and 8. And of course, our transversal line is named as line A. Just a note, guys, even if the lines are not parallel, it can still be cut by a transversal line. If the transversal cuts across lines that are not parallel, the alternate interior angles have no relationship to each other. All we can say is that each angle is the alternate angle to the other. But both the parallel and non-parallel lines will form the interior part, which is the space inside the two lines when cut by a transversal. Okay, from there, we will have the interior angles. Interior angles are defined as angles formed between the two lines. So what are those interior angles? Okay, so from the figure, we have angle 3, angle 4, angle 5, and angle 6 as our interior angles. Of course, if we have the interior part, we also have the exterior part, which is the space outside the two lines. And then again, we have the exterior angles. Angles found outside of each side of the two lines. So what are those angles found outside of each side of the two lines? So those are angles 1, 2, 7, and 8. Okay. Now that you are familiar with the exterior and the interior part, let us now consider finding the pair of angle in this given figure. Have a good look at the figure, and together we will determine the pair of angles when a non-parallel lines M and N are cut by transversal line R. The first pair of angle that we have here is called as alternate interior angles. Alternate interior angles are a pair of non-adjacent interior angles on opposite side of a transversal. So looking at the figure, what are the alternate interior angles? So those are angles 3 and 7, angle 4, and angle A. So apart from that, we also have the same side interior angles, and defined as interior angles on the same side of a transversal. So consider the same side of the transversal. Looking at the interior part, we have angles 3 and 4 and angles 7 and 8 as our same side interior angle. Okay, so there is more. Pair of angles that we have is the alternate exterior angles. Alternate exterior angles are a pair of non-adjacent exterior angles on opposite side of a transversal. Okay, so those are angle 1 and angle 5, angle 2 and angle 6. For the fourth pair of angles, we have the same side exterior angles. Exterior angles on the same side of a transversal. Those are 1 and 6 and 2 and 5. Okay, so let's proceed. Still on the pair of angles that we can derive from this figure is called the corresponding angles. Corresponding angles are a pair of non-adjacent interior and exterior angles on the same side of a transversal. Okay, so we just have to look at one exterior, one interior on the same side of the transversal. And the examples will be angle 1 and angle 7, angle 2 and angle 4, angle 3 and angle 5, angle 6 and angle 8. Okay, next is the vertical angles. Vertical angles are a pair of angles sharing a common vertex and opposite each other. Okay, common vertex and opposite each other. So we have the example as angles 1 and 3, angles 2 and angle 8, angle 4 and angle 6, angle 5 and angle 7 as our vertical angles. Okay, so now that we have determined the pair of angles formed here, let's now proceed with the properties of parallel lines cut by a transversal. Okay, so you take a good look at this figure, guys. Okay, so we have these two parallel lines cut by a transversal. So we will consider the interior angle first. Okay, from that interior part, we have the interior angles. So we have the alternate interior angles. And alternate interior angles are congruent. Angle 3 and angle 6 and angle 4 and angle 5 are alternate interior angles. Therefore, angle 3 is congruent to angle 6 and angle 4 is congruent to angle 5. There we have it. Number 2, same side interior angles. Same side interior angles are supplementary angles, meaning when you add those two angles, they are equal to 180 degrees. So, if we have angle 3 and angle 5, angle 4 and angle 6 as same side interior angles, therefore, they are supplementary angles. So that the measure of angle 3 plus the measure of angle 5 is equal to 180 degrees, and the measure of angle 4 and the measure of angle 6 is equal to 180 degrees. More on properties of parallel lines cut by a transversal. So the same figure, guys. This time we will consider the exterior part. So on the exterior part, of course, we have the exterior angles. For number 3, we have alternate exterior angles, and alternate exterior angles are congruent. So on our figure, we have angle 1 and angle 8, and angle 2 and angle 7 as alternate exterior angles. Therefore, we can say that angle 1 is congruent to angle 8, and angle 2 is congruent to angle 7. Number 4, the same side exterior angles are supplementary angles. So same side exterior angles, we have angle 1 and angle 7, and angle 2 and angle 8 are same side exterior angles, and they are supplementary, so that the measure of angle 1 plus the measure of angle 7 is equal to 180 degrees. And the measure of angle 2 plus the measure of angle 8 is equal also to 180 degrees. Okay, so more on the properties of parallel lines cut by a transversal. This time we'll consider both the exterior and the interior part, because we have now the corresponding angles, and corresponding angles are said to be congruent. So those corresponding angles that we have here that are congruent are angle 1 is congruent to angle 5, angle 2 is congruent to angle 6, angle 3 is congruent to angle 7, angle 4 is congruent to angle 8. Okay. So to continue, the last property of parallel lines cut by a transversal, here we have again to consider both the exterior and the interior part. And now we have the vertical angles, and vertical angles are also congruent. Vertical angles are 1 and 4, so they are congruent. Angle 2 is congruent to angle 3. Angle 6 is congruent to angle 7. And angle 5 is congruent to angle 8. Okay. So now that we have completed all the vital concepts in our topic, it is about time to practice what you have learned. So let's practice. From the direction, using the figure where A and B are parallel lines and C is a transversal line, name the following. So take a good look at the figure, guys, to answer what is required. Okay, so for the first statement, what are the pairs of alternate exterior angles from the figure? Okay, so if your answer is angle 1 and angle 8, angle 2 and angle 7, then you are correct. Number 2, determine the pairs of corresponding angles. And that is, or those are angle 1 and angle 5, angle 3 and angle 7, angle 2 and angle 6, angle 4 and angle 8. Correct. Number 3, pairs of alternate interior angles. Pairs of alternate interior angles are angle 3 and 6 and angles 4 and 5. For number 4, you have to determine the pairs of exterior angles on the same side of the transversal. Okay. If your answer is angle 1 and angle 7, angle 2 and angle 8, you are right. Number 5, pairs of interior angles on the same side of the transversal. So for the last item, you have to determine the pairs of interior angles on the same side of the transversal. So those are angles 3 and 5, angles 4 and 6. Okay. So there's more. Let's try once more. So consider the given figure. This is the direction. In the diagram, D is parallel to E. Determine whether each pair of angles are corresponding, vertical, alternate interior angles, alternate exterior angles, or same side exterior angles of the transversal. Okay, so here is the given. Okay, so take a good look at the figure before giving your answer. Okay, so for number 1, we have angle 3 and 8. Angle 3 and 8 are same side exterior angles, correct? Number 2, the given is angle 2 and angle 8. So angle 2 and angle 8 is corresponding angles, right? Number 3, angle 4 and angle 3. Look at the figure. The location of angle 4 and angle 3, they are opposite. They are vertical angles. For number 4, we have angle 6 and angle 3. Angle 6 and angle 3 on the figure states that they are alternate exterior angles. Correct. Number 5, angle 7 and angle 2. Angle 7 and angle 2 from the figure is alternate interior angles. Okay, so now that you have learned this topic, we will now move a step higher. So we will just try to answer the question here. How to find the measure of an angle with equations when two parallel lines are cut by transversal. So to find the measure of an angle with equation when two parallel lines are cut by a transversal, it is important that you are already familiar with its properties. So those are the ones that we discussed a while ago. So here is the diagram. In the diagram, M is parallel to N, and A as the transversal. Complete the following statements. So we have 3 statements here, and all this statement is related, of course, to the figure. So for statement number 1, if the measure of angle 1 is equal to 95 degrees, then what is the measure of angle 5? Number 2, if the measure of angle 2 is 75 degrees, then find the measure of angle 7. And for number 3, if the measure of angle 3 is 60 degrees, then find the measure of angle 5. Okay, so this is problem number 1. So we will take it one by one. For problem number 1, given the measure of angle 1, which is 95 degrees, and we are to find the measure of angle 5. So the best thing to do here is to look at the figure. Locate where is angle 1 and angle 5. Okay, so from the figure, it is stated that angle 1 and angle 5 are corresponding angles and they are congruent to each other. So with that, given is measure of angle 1 is equal to 95 degrees. Congruent angles have the same measure, therefore, the measure of angle 1 is equal to the measure of angle 5. Substitute 95 in place of measure of angle 1, so we have 95 is equal to measure of angle 5. And by applying symmetric property, we can now determine that the measure of angle 5 is equal to 95 degrees because angle 1 and angle 5 are congruent to each other. Okay, so let's continue for problem number 2. In problem number 2, we have the measure of angle 2 as 75 degrees. Then the measure of angle 7 is unknown. So again, take a good look at the figure. Determine the location of angle 2 and angle 7 to determine the relationship. And as seen, angle 2 and angle 7 are alternate exterior angles, and they are congruent to each other. So we can say that from the given, the measure of angle 2 is 75 degrees. They are congruent, so therefore, the measure of angle 2 is equal to the measure of angle 7. Substitute 75 in place of measure of angle 7. So we have 75 degrees is equal to the measure of angle 7. Apply symmetric property of equality to get the measure of angle 7 as 75 degrees. Okay, let's proceed. For number 3 problem, we have if the measure of angle 3 is 60 degrees, then the measure of angle 5 is blank. Again, the same technique, you just have to take a close look at the figure, determine the location of angle 3 and of course angle 5, find the relationship between these two given angles. So based on the illustration or based on the figure, angles 3 and angle 5, angle 3 and angle 5 are same side interior angles and they are supplementary to each other. So for the solution, given measure of angle 3 is 60 degrees, since two angles are supplementary, we can say that the measure of angle 3 plus the measure of angle 5 is equal to 180 degrees. Substitute 60 in place of measure of angle 3. So we have 60 plus the measure of angle 5 is equal to 180 degrees. Apply addition property of equality. So we have 60 degrees minus 60 degrees plus measure of angle 5 is equal to 180 degrees minus 60 degrees. Therefore, from that equation, we can determine the measure of angle 5, which is equivalent to 120 degrees. Okay, so now we know that the value of measure of angle 5 is equal to 120 degrees. And 120 plus 60 is equal to 180 degrees, and they are supplementary angles. Okay, so let's level up. For problem number 4. Okay, so for problem number 4, it is stated that you have to find the measure of each numbered angle in the figure below. Consider the parallel lines are cut by a transversal. So our numbered angle is angle 1 and angle 7. And for angle 1, we have 5x plus 15 as the given value. And for angle 7, we have 3x plus 5 degrees as the given value. So the technique in solving this problem is to examine the figure carefully and then identify the kind of relationship that exists between the given angles. Since angle 1 and angle 7 are same side exterior angles, therefore, they are supplementary. Okay, so we can say that a measure of angle 1 plus the measure of angle 7 is equal to 180 degrees. Okay. And then substitute the value of the measures of angle 1 to the given equation, that is 5x plus 15. And also substitute the value of the measure of angle 7 to the given equation. We have 3x plus 5. We now have 5x plus 15 plus 3x plus 5 is equal to 180. Then, you have to combine similar terms. Combine 5x plus 3x to arrive at 8x, and then combine 15 and 5 to arrive at 20. So our new equation now is 8x plus 20 is equal to 180 degrees. So we have to apply addition property of equality on this part. So we have 8x plus 20 degrees minus 20 degrees is equal to 180 degrees minus 20 degrees. So with that, guys, we can have the equation 8x is equal to 160 because 20 minus 20 is 0 and 180 minus 20 is 160. So we are left with 8x is equal to 160 when we simplify. Okay, so we need to determine the value of the variable x. And to do that, we have to apply the multiplication property of equality. That means we just need to divide both sides of the equation by 8 so that x will be equal to 20. Okay, so now that we know the value of x and x is equal to 20, we can now find the measure of angle 1. So from the figure, we just have to substitute the value of x to the given expression. The measure of angle 1 is equal to 5x plus 15 as given, but we know the value of x as 20. So we just have to substitute 20 to x. So we have 5 times 20 plus 15 is equal to 115 degrees. So the measure of angle 1 is equivalent to 115 degrees. To find the measure of angle 7, substitute the value of x to the given expression. Measure of angle 7 is equal to 3x plus 5. Substitute the value 20 to x. So we have 3 times 20 plus 5. So that will give us 65 degrees. That means that the measure of angle 7 is 65 degrees. If you want to check your work, we can do it by saying that measure of angle 1 plus measure of angle 7 is equal to 180 degrees. Substitute the value we obtained for measure of angle 1, which is 115, and do the same thing with measure of angle 7, which is 65, and equate that to 180. Take the sum of 115 plus 65, that is 180, and it is equivalent to 180. Angle 1 and angle 7 are same side exterior angle, and they are supplementary angles. Okay, so I hope this is clear to you guys so that we can proceed with problem number 5. So for problem number 5, the figure shows two parallel lines and a transversal line. Find the measure of each numbered angle. So this is just like the one that we previously have. But of course, you have to check the relationship that exists between angle 1 and angle 7. Okay, so what is the relationship between angle 1 and angle 7? Angle 1 and angle 7 are alternate exterior angles, so they are congruent. We can say that the measure of angle 1 is equal to the measure of angle 7. Congruent angles have equal measures, right? So substitute the value of measure of angle 1 as 5x minus 64 and the value of measures of angle 7 as 3x. Okay, then from this, apply addition property of equality or the APE. We have 5x minus 64 plus 64 is equal to 3x plus 64. Negative 64 plus 64 will cancel out. So we are left with 5x is equal to 3x plus 64. Again, we need to simplify by applying again addition property of equality. And we have 5x minus 3x is equal to 3x minus 3x plus 64. 3x minus 3x is 0. So we are left with 2x is equal to 64. Remember that 2x came from 5x minus 3x. So determine the value of x by dividing 2 to both sides of the equation. X will be equal to 32. Gets? Okay. Since x is equal to 32, we have to find the measure of angle 1. Substitute the value of x to the given expression. Angle 1 is equal to 5x minus 64. But we know that x is equal to 32, so you just have to substitute 32 to x and then perform the indicated operation. So 5 times 32 minus 64 is 160 minus 64. Therefore, we can say that measure of angle 1 is equal to 96. Okay, so now that we know the value or the measure of angle 1, we can proceed in finding the measure of angle 7. So, again, we have to substitute the value of x to the given expression. Angle 7 is equal to 3x. X is 32 multiplied by 3. Then we have measure of angle 7 as equal to 96. Okay. So with all the examples, I am pretty sure that you will be a step better in your problem-solving skills, guys. Okay. So how do you find the lesson for this week? Sometimes it's quite amazing that the relationship that exists between the given figures or the given quantities makes problem solving a lot easier. Do you agree? I hope so. Okay. Again, I hope you learn a lot from this week's topic, guys. So let us summarize the lesson that we go through by answering this crossword puzzle. So we will begin with all the numbers across, followed by all the numbers down. There. For number 1 across, blank are lines in a plane which do not meet. So what are those lines? If your answer is parallel lines, correct. Number 3, a line that passes through two lines in the same plane. And that is transversal line. Number 5, blank angles are angles with exactly the same measures. And that is congruent angle. Number 6, blank angles found outside of each side of the two lines is called as exterior angles. Correct. Okay, so now that we're done with all the words across, let us consider all the words down. So for number 2, we have blank, a pair of angles sharing common vertex and opposite each other. And that is vertical angles. And for the last one, number 4, blank are angles formed between the two lines. And that is interior angles. Okay, so that's it, guys. We're done with Q3, week 3 topic. This is Cristina T. De Vera, your teacher broadcaster for today, now signing off. Thank you.
Makinig, manood, nasa teleradyo. Makinig, manood, nasa teleradyo. Teleradyo, Teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito, tiyak ang pagkatuto. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo.